analysis. It's a continuity to what Eyal talked to you in class, and what Eyal talked to you, if you remember, November, December, the first meeting here in. So, why to do soil analysis? It costs money. Why to do it? I know some of you are afraid. If something costs money, it means it's not good. Yeah. Unless if it's a Coca-Cola, sweet chocolate, fries, pizza, and electronics. All the rest, if it costs money, it's not good. The important things that cost money are not good. So why to do soil analysis?
In order to know soil constituent.
What?
In order to know the soil constituent.
Okay.
Determine what type of crop to grow.
Correct. Correct these answers, and there's also more. We're doing analysis to the soil and also to leaves. Okay, the common analysis is soil. Okay, we do it usually before planting. Depends if it's trees or vegetables, but if it's seasonal crops, we do it before planting. If it's trees, we do it at the end of the season / at the beginning of the season to know what is the situation. Okay, and this is for the soil. Leaves we do in the middle of the season. What is again depends on the crop, like before flowering or after flowering. Each crop and its best. What is the most appropriate time to sample? And the leaf gives us like an online situation. Like why online? Because it's what is the situation now. So if there is a problem, we can fix it immediately. And in the soil, it gives us like a very big picture. What is the condition? Okay, so we can make. We have, if it's the end of the season, we have time to do adjustments towards the beginning of the season. Or if it's before planting, of course, we have a lot of still planting time. We have time to figure out what to do. So the soil analysis, like you said, helps us to understand what crop is more or less suitable. But in general, today we can grow almost all crops in any type of soil. But we need to know, to be able to do that, we need to know what is the soil texture, EC, pH, salinity, organic matter, etc. All these parameters, so we can determine we chose for example lychee, okay, but then how many drip lines, what is the spacing, if we're going to grow on ridges, on flat plot, and other things like that. Okay, now the samples are sent to a field analysis lab. We have one inside college. Okay, it belongs to the same company that operates this farm. Okay, Tzemach Technologies. Okay, hopefully we're gonna also do a short tour in this lab in very small groups, like 10, maximum 15, I think. Okay. In the past, we used to study on Fridays, so it was empty on Fridays, so it was very easy to do it. But since we started studying on like Sunday, Sunday to Thursday, as long as people work there, it's very hard no room to bring a group. So, but this year we'll try again. In the previous years they didn't allow it, so hopefully they will happen. So you'll see the lab and what they do. But in general, the farmer samples the soil and sends a sample. He needs to take it to the lab. Now, how to sample? There are instructions on the website of each lab. But in general, each crop, if it's leaves, each crop has the methodology to sample the leaves. Okay, so banana we need to take from the third leaf, in the middle. In citrus we take from the middle stem, from this shoot, etc. Okay, but so it's a bit different. But in soil, it's the same idea. Usually, when we sample before planting, So it doesn't matter where we sample, okay, in the soil. But let's say this table is the plot. We need to, for the rule or finger rule, like in general, for every 1 hectare, it's 1 kilo, 1 sample. But this 1 sample is taken from different places in this 1 hectare. So for example, a table, so we make like a W. Maybe you learned it in statistics or in, okay, it's a common way to sample plots. We take a sample from here, from here, from here, from here, something like that, okay? In this case, we cover, statistically, we cover the whole character of the plot. We have 1 sample, but it's based on few areas in the plot. This amount of sample is taken to the lab, they dry it. It can be 65 degrees, it can be 100, depends what is the analysis that we want. If we do it in 65, we can also take out NPK and macro, micronutrients and other things. If it's 100, it's only salinity and pH. Okay, so it depends. The farmer can tell the lab, I want only EC and this, so it will cost, let's say, 70 shekels. But as the more analysis results we ask from it, more tests they need to do, the Excel sheet starts to build up, and it can be a few hundreds of shekels for 1 sample, but you can calculate it for 1 hectare, let's say 1,000 shekels, it's less, but let's say 1,000 shekels maximum. So it's not a lot of money once a year, if you compare it to labor, water, fertilizer. Okay, but for a small plot, okay, 1 dunam, so you think, it doesn't, okay? So we will see how we can do some stuff by hand after I'll finish blah blah. We'll, okay, because all day I have to prepare, so we'll go there. Okay, so if we sample, so they dry it, afterwards they grind it, and then they take, they measure, let's say, half a kilo of soil, okay, for half liter of water. Now the water they use is distilled water. Again, depends what is the test. This is for EC and pH. They make saturated solution. This is what we're going to do today. They take the known amount of soil that represents the whole 1 hectare. Okay, they ground everything, they mix it, they take half a kilo or a kilo. Then they add also a measured amount of distilled water. The distilled water, they absorb the minerals, they mix it very well, they let it rest, the soil sound. Afterwards, they filter it through the Watman paper, and they check what they need from the pH. You see, so it depends on the nitrogen is this method, phosphorus is this. Understood?
Yes.
Now, if we sample before planting, like I said, you take from wherever you want. If we plant during growth, usually we take next to a drip line, like 10 to 15 centimeters from a drip line. Why? We need to know also, when we check EC, we need to check the EC where the plants are located, where the drippers. Why? Because the salts accumulated from the water and also from the fertilizer. In this area, it's also mainly from the water, not only from the fertilizer. Okay, so we need to sample next to the drip line. Now a sample is done, a sample like that is done usually from 0, אתה עכשיו פה, אני נחתך לשם, אין בעיה. אני אלך לשם, אני אחכה שאתה תעבור ואני אלך לשם. We will move there, they will come and they...
אז מה יגאל קולי?
So a soil sample is done usually from the depth of 0 to 30.
Yes.
Okay, a 0 to 30. Okay, but there's another way of sampling is to doing a soil survey. This is we do only before planting. A big shovel comes and dig 1.5 square meter hole, okay, of pit, big hole, 1.5 meter deep. Okay, so 1.5 cubic meters. Eventually we get it. And then we take samples from 0 to 30, 30 to 60, 60 to 90, 90 to 120, sometimes 120 to 150. If you remember in the irrigation exercise, in the macro Excel file that calculates irrigation, it asks you to enter parameters of the soil character. Now you didn't do the soil survey, so I told you to leave it empty. But in reality, farmers do it before planting. They check how much and so now this is the I'm not going to do it here, it was very difficult to dig here. Okay. So let's go next to the vegetables. Don't touch the vegetables, huh? Go next to the banana.
And now we have it.
I told you to take only from one. Now,
To go now.
okay. So this is it comes in different. This is the small one. It can come a bigger one. We have 30 centimeters, 60, 90. Okay, so when we start, okay, we will now dig 90. We'll take one sample and put it. Usually we remove just the beginning. It's something. Okay, now we start. Salim.
Ega force.
Yeah.
Yalla.
Soon you will do it. Don't worry.
Yalla. Yalla Vishay, yalla.
Okay. So we didn't get till the end yet. It's very sticky. Yeah, you can also do it with a shovel, but power.
He's tired.
Enough food. You will soon do it, you'll see, he will not move even a little bit, you say. That's what the students said before, and he stayed in the same place. But yeah, I'm tired. If you knew what I did till I got here to Tzemach Farm, you say, wow. מה אתה רוצה לעשות? same. אותו דבר. אותו דבר. דבר is a thing. עכשיו. Which farm you're from?
Chocolate.
Okay, so this is the 30 centimeters. Yeah. Now you will do to 60. Oh, yeah, we'll see. No, but I wanted. Okay, look. Start. We can see already that there is a little bit more stones at the bottom already. A little bit, not a lot, compared to the 15-20 centimeters, and then the. Okay. You can take out the soil. Take it out. No, it's just taking out soil.
He's a madman.
Meanwhile, I will see.
You can go get that banana. From mushroom.
No, this put on the side in purpose to see the difference. Yeah. No, it's okay. Only this. I will. Another student asked me. No, so it's easy. Yeah. Good job.
It's very hard. I can do it. You teach me. Okay.
When you get to the 60 that it will be next year maybe, Okay? Put the 60 here on the side and continue to the 90. I'm going to bring a knife. Hey, get away from the bananas. Come close. I will bring a knife.
Now the t-shirts are wait, because you have a guy.
Clockwise.
akatele mumjambule video
Oh, chifika basi.
mwana alivise
Hey, daddy.
Michael, I don't know if you're going to ayo check ayo tapi nditofela nyamaranga ndimakudalira
iwe ndo timakudalira potusa maolenje ichichakoza kuchipangira
Heavy soil, we already know, but we can also see it. Okay, it's not breaking up a little bit even. And if it will dry, it will start cracking. We can see 30, 60, and 90. You can see already that the 90 starts to have more. There is a lot of calcium, limestone. You see?
Yeah.
The original stone in this area is lime. Okay, so that's why the soil, and as we go east, okay, the soil become more alkaline. So here it's around 7.8, there it's already 8.2. It's only because of the calcium. This is why we do not apply also calcium in our fertilizers. We also have it in the water, irrigation water. We also have it in the soil. So also sulfur, like in your countries, you apply calcium, magnesium, and sulfur. Okay, you have like, I know, 21 plus sulfur, 4% or whatever sulfur. We do not use it, only in hydroponics when we grow in water. But like I said, I recommend you do once water sample of your irrigation water. You'll know what you have. You check the levels. It's good, good. Maybe you don't need to apply. Usually you need to apply calcium, magnesium, but maybe you don't need. But you need to check, not to waste fertilizer, because these fertilizers, magnesium is also expensive. Same to the soil. Do once to get the picture, so you know. Afterwards, you'll do what we're going to do now. Okay? Just check the EC to monitor you're not doing damage. Okay, especially in trees, in vegetables. Okay, so now, no, this we don't need anymore. Now, what we're gonna do, what they do, now we'll show you what they do, like in the saturation solution. They take the sample after it's dry, okay, imagine it's dry and grinded, okay, and they add, let's say we have here half a kilo or kilo, they add the measured amount of water, okay, and they mix it very well. Then they let it sit. Afterwards, the soil, they mix it a few times during the day. There is a whole protocol how to do it. Then it stays, and they take the upper part of the water, they filter it, and they do all the tests relevant that they can take from this saturated solution, like EC and pH. And I think that's it from this method.
What is the reason of drying that soil?
Look, you want to mix it very well. This you cannot mix it. It takes time. Time is money. You want to do so it makes it faster and more efficient, because you take, sometimes it's many samples from one plot, and you make from, I told you, one sample. They mix it together. So if it will not be grinded, it will not be. You cannot take exact 100 grams from here. You understand? It must be grinded. So this is why. You can also do it like that, but then you need to mix it It's heavy soil, like we did it on Monday. Eventually it's dissolved, but we mixed it, and after 30 minutes again and again, you need to push the.
So what if it is a sandy soil?
So it's much easier. You just mix it.
No reason for drying before testing.
No, it will be also more difficult to. But sand, there is not. No one is going in sand. In sand, like there is no one. Okay, there is like sandy soil. Yes, so there is also already clay inside. So they do the sample.
Clay and the silt.
Okay, sandy soil means that the concentration of the silt is lower. Yeah, here it's like 60%. 50, I don't know. But, so now we'll go to that table.
Leave it for the next group.
This thing?
Okay, just a little bit out so everybody will have room.
So that's a bit.
A bit, you are a bigger group. Out. Each one will do 2 steps back. I also did 2 steps back. Each one will take 2 steps back. Okay, what we see here, okay, this is from Monday. Okay, this is from Monday. I will not mix it because then the water will become dirty again. Okay, we mixed it. Okay, it was very hard to mix it. I don't know if it was a good mix, but for the example, you will see the results. Okay, and I brought you here 2 types of water to show you the EC differences, and we will check EC and pH. We have here, one was taken by someone. Okay, we have, this is EC meter, expensive one, can last many years, 10, 20, 30, 40. Huh?
How many dollars?
1,200 shekels. And we have the nephew from China that will last maybe 1 or 2 years, but will cost 15 shekels. 15 shekels? Yes. Okay. With the battery, maybe 20, but never mind. Okay? But this one is not working fine, specifically. I think because I left it in the whole summer in my car, so it's very hot summer. Soon you will feel it. So it melted. Also, but we will check with them both. This is the pH, again, expensive, China. Why China? Okay, no, China, they have good things. Okay, so now we'll check the EC. Now, when we work on EC units, okay, there is dead Siemens, but we work on, the battery is dead. Yeah, the battery. Shit. So I'll do it fast. So the EC here is 1,000. Okay, this is drinking water. 1,000 micro Siemens. Okay, it means 1 Siemens. One is we divide by 1,000. And this is 260. This is desalinated water from this place. Remember we talked about this one? From the desalinated water. Now let's check the EC here. Okay, 620. Okay, now I'll wash it. Now the salinity of the soil is supposed to be equal to the irrigation water, around 1, something like that. Okay. But when we sample, remember, where do I need to sample? I told you. Next to the dripper, right? Yes. We sampled not next to a dripper. So it's not representing the real salinity that us as farmer want to know. This is between. So why the salinity is low? Now it was also the rainy season. Now, recently, 40 millimeters of rain, irrigated. Rain, what salinity is the rain? The salinity of rain. Distilled. It's like distilled water. Or very close to very low salinity. 0.0, almost nothing.
Amen.
So the rain is our reset for the saline soil. Okay, the rainy season, but we need like 40 millimeters and more, so it will do a real wash. That's why the salinity is not so high. Okay? So you see, with a very simple way, what we did, we took out, we put water. But we must use distilled water or desalinated. We use desalinated because that's what we have here. But distilled water is the protocol. We leave it and then we check. That's it. Very simple.
Okay.
You saw? Now pH. Also, I told you we can grow in every soil. pH in every soil we can, but sometimes where it's acidic. Okay, no baya. Let's start with this. Look, usually water it's around 7.
7
Yeah, around 7 neutral. It will start to go down. pH takes more time. Okay. Here also, it will start to go. It's supposed to be around 7. It starts to go. It takes more time. And this one, because it's from the soil, it's supposed to be higher. It's supposed to start going up, closer to 8. Okay?
Yeah.
That's in general. So, but if you get the pH is acidic, less than 5.5, less than 5, and you want to grow in this soil, you need to add limestone. Where is the other? Where is the battery? Where is the cover for this? No, not for this. Now I'll show you the Chinese one. It works, but the results are not. Doesn't make. They're not like the other one. You see, they're.
It's for China.
See, 700 instead of 1,000. Okay, it's like, and this is. It's not accurate. This is 300. It needs to be maybe calibrated.
It's like a toy.
Yeah, it's a toy. And this is so it's 540. So it's almost, but it's not.
It's not good.
So so that's it. Questions?
So it's all about soil analysis. You are done.
Yeah, I'm done. Yeah.
What about the availability of nutrients? How can we calculate the nutrients that are available in this way?
Availability of nutrients.
Yes.
Look, when the pH is alkaline, the macronutrients are more. You'll see it in the nutrient plant nutrition course, but the NPK is more available. When the pH of the soil becomes more and more acidic, most of the macro anyway, becomes less available. Okay, and the micro becomes more available. Okay, that's why here mainly we apply, instead of, additional to NPK, we add iron or some other micronutrients. But we don't add the calcium and magnesium because they are available. But if your soil, in your countries, most of the soil is acidic, so you need to apply calcium, magnesium, sulfur. These, you can call it secondary macro. But still, they're macro, very important. Availability is fertility of the soil, not compacted soil. It's like the beds we did, organic matter, very important. For example, in my garden, in my house, I see places, because I applied it by hand, the dung, places that got more dung compared to others. It's amazing how the soil looks, amazing. Okay, so organic matter. But the dung, it's better to, here in our vegetable plot, we add the dung and make the bed and plant, but it's recommended to make the tillage. You can make the bed and let it at least 1 month, better 2 months, to compost a bit from the dung. Okay?
So chemically, how do we test the nutrients availability?
That's already, first of all, there are kits. The best thing is to send to the lab. This is the real thing. If you want to do it yourself, nitrogen, it's a problematic to measure. There is like something similar to this, but it measures only nitrates. What about the ammonium? It's a problem. Okay? You can get, like, I forgot it in the car, instead of using these electronic meters, there is a very simple lacmus paper to take pH, and the additional paper, it's in the car, I forgot to bring it. Much cheaper than this. They are less accurate in that 0 point something, 7 point, but it gives you a picture. Also works fine. Okay, you can buy it online or I'm sure you also have it in. If you have a laboratory and you have, okay, you can maybe buy it direct from them, or they can tell you where they buy it from. But in general, availability, it's what I said: fertility, organic matter. Now, when you apply the fertilizer, the quantities students always told me in the years, you apply a lot, too much. Then you like twice as much than we apply here sometimes. You apply in the seeding or planting, and then when it gets here, and that's it. It's not the right way. We apply or every day, or once a week, or every 2 weeks, or every 3 weeks, or every 4 weeks, depends in the season also. Okay, and you will learn it in the plant nutrition, and also we'll talk about it in the vegetable plots. But availability, it's the pH. Like I said, as the pH goes up, it's the macro more. As the acidic, the micro more, and the macro less.
Because
And if the soil is compacted, if the soil is not enough oxygen, if it's like compacted again, it will be more difficult for them.